find more off of those z-scores. Who was all gone Friday? You're gone Friday, come up here and grab a table here. So hopefully you watched your video so you understand what's going on.
I don't know your YouTube channel.
Huh?
I don't know your YouTube channel.
You literally just search my name, Clyde. And it pops up.
Other channels, maybe.
Uh-huh.
I want to have a link on Schoology. I think so. What's that? I think so. Maybe I didn't put it in my settings.
No, that noise.
Yeah, I think that was.
That's not my phone. I have it on Do Not Disturb. Try and get me again.
I just heard it from over there. I don't know who it was. It's all right. Okay, so Friday we talked about z-scores. Okay. Z-score, that's the distance, the number of standard deviations away from the mean, correct? When you go right of the mean, that is, you hit that? That's positive, right? Okay, if you go left of the mean, that's a negative z-score. Again, just the number of standard deviations away from the mean. That was the formula, correct? The z-score is equal to your score minus the mean divided by the standard deviation. Okay. Friday, I gave you a score, mean, and standard deviation. We calculated the z-score, correct? Now, we're going to find a score associated with the z-score. So I'll give you the z-score, the mean, and standard deviation. We can just manipulate that formula in order to find that, as long as we know those three things, correct? Okay, so that's how we're going to start. Okay, so the scores in the last Algebra 2 quiz were normally distributed with a mean of 71 and a standard deviation of 4. Jake's score was 2.1 standard deviations above the mean. And if it's above the mean, that means it's going to be positive, right? So 2.1 standard deviations above, that's a z-score of positive 2.1. If I was to say below, then it would be negative, correct? Okay. What was his score? So let's just do a little sketch here. Try to get a visual of the situation. On a normal curve, what falls right in the middle? The mean. Okay, we had a mean of 71. One standard deviation away, what would that put us at? Above. One standard deviation above. 75. Two standard deviations above. 79, right? And 83. Below, that puts us at 7. Two standard deviations.
63.
3 standard deviations.
51, 59.
79. Now, Jake was 2.1 above, correct? 2.1 above. 1, 2. So right about there is where Jake is, right? So what's a score you could expect? What's a range that you could expect Jake to have gotten? What two values would he be between for his score? 79 and 83. Okay, and since it's 2.1, it's probably closer to that 79, right? So that's what we're looking for. What's the actual score that he got? Okay. So let's just break down what we know. Do we know his score? Score he got on the quiz? No. We know his z-score though. He was 2.1 above, right? So positive 2.1. We had a mean of 71 and a standard deviation of 4. So if I just go and plug that in to the formula, that's going to get us 2.1 equals, we don't know x, minus the standard deviation over minus the mean over that standard deviation.
I thought you said it's gonna be plus.
What's
Positive.
that?
I thought you said it's gonna be positive sign.
The z-score, yeah.
Oh.
Is the z-score positive?
Right.
Is that an equation I can solve for x? Yeah. What's my first step? Multiply by 4. That's going to cancel those. So that will give me 8.4 equals x minus 71. Last step. I had 71, which will give me a score of 79.4. Is that kind of an answer we expected from the curve? Is that between 79 and 83, right? Set a little closer to 79. Is that pretty close to 79? It's a word problem also, right? So we should really be writing a sentence. What would you write for that sentence? Jake scored a 79.4 on the quiz, correct? Alright, so, same quiz now. Alessandro score was 1.4 standard deviations below the mean. What's Alessandro's z-score? Negative 1.4. Mean and standard deviation didn't change at all, right? We're just trying to find her score. Now, negative 1.4. It's going to be about there, right? What was it, 1.4? So what's the score we could expect she got? Something between 63 and 67, right? 64, 65 maybe. Okay, that's what we're looking for. So again, just plug in what we know into the formula. Negative 1.4 equals x minus that 71 over 4. The steps to solve it, is that going to change at all? The only difference is that negative 1.4, isn't it? Multiply by 4. Negative 5.6. Add that 71. What do we get there? .4. Someone double check that for me. Right?
Yeah.
So Alessandro scored a 65.4%, right? Questions there? We know 3 of the 4 things, right? And if I know 3 of the 4, I should be able to find that last one. If we have a formula for it, which we do. Questions on those 2? Okay. Let me know when you're good, bud. Okay, go ahead, give that next one a try. is normally distributed with a mean of 7.7 pounds, a standard deviation of 1.3. Your nephew's weight was 1.2 standard deviations above the mean. How much did he weigh? Okay. So if he's 1.2 standard deviations above, okay, 7.7, then we got 9, should be a little over 9, right? One standard deviation above would be at 9, a little bit more than that if he's 1.2 above. Okay, we get z-score of 1.2. Should it be positive?
Yes,
Why again?
because it's above.
Above. Mean is 7.7, standard deviation of 1.3, and we're looking for what your nephew actually weighed, correct? So, 1.2 equals x minus the mean over the standard deviation. What are my steps to solve for that score then?
Multiply by 1.2.
Multiply by 1.3. What do I get for 1.3 times 1.2?
1.56.
1.56. Last step.
Odd 7.7.
9.26. So your nephew weighed 9.26 pounds. It's a big baby. Questions there? Not too bad for those ones, right? Okay, so everyone have your table out. Okay, now we're going to find z-scores associated with areas. Okay, the probabilities. Now, if you remember, on this, okay, went to the z-score and it gave me the area to what side of the z-score? To the left. Okay, you need to remember that. Because we had that conversation about if you go Google one of these, you might not pull up the same one, right? There's other ones out there that give you the area to the right. Sometimes it just gives you area to the mean. All different types. Make sure you're using this one. If you need another one, come find me and I'll give you another one. I made extra copies. So-
Mr. Page,
Yes.
would we be allowed to use these on like a test or quiz?
No, you gotta memorize all the numbers.
Oh, Marty Harbaugh.
Yes, you'll have it for the test and quiz. Okay. Now, okay, so sometimes we need to find x or z that corresponds to the given area under the normal curve. So we got this area under the curve. Okay, this is where our z-score is right here. We don't know the z-score, but I do know the area. That area is to the left, right? So how can I find that z-score?
Find it on the chart.
Find it on the chart. Now, when you go to the chart, you can go to the positive or negative side. Positive. Okay, so you just go
1.23.
to the chart, and we're looking for, what was it, 0.980? 8907?
Yeah.
8907.
1.23.
1.23, just like Andrew said. That's all there is to that. Okay, that's it. You need to be able to find z-scores associated with the probability. Okay, come test or quiz time, I'm gonna give you guys a brand new fresh one for the quiz, or for the quiz, you'll probably just use the one you got. Test, I'm gonna give you a brand new one. Okay? There's a lot of numbers on there, right? Okay, so if you have highlighters, bring a highlighter, probably help you keep track of all those numbers. It's very easy to get them all mixed up. Okay? So I'll give you guys, maybe I'll have some highlighters too. But if you have highlighters, bring them. Okay? So 1.23. Okay, same thing here. Got the area to the left of it, right? So what are you going to do to find that z-score? Find it on the table, right? So go ahead, find it. 8686, and it should be positive again, right? 8686, what do we get? 1.12.
No?
And if it falls to the right, or if you just had the area to the left and it's greater than 0.5, it's going to be positive, right? Again, the mean puts you right at 50%. So if it's greater than 50%, it'll be to the right. Okay. What side of the table are you going to look at here? Negative side, right? We're on the left of the mean. Again, you just need to find that, 0.0158. 0.0158. You guys find it? Negative 2.15. Okay, so if I give you the area to the left of it, it's pretty easy, right? You literally just look it up and it's done. You just write down that z-score. Now, what if I was to give you the area to the right though? Can I still figure out the area here? What is that whole area under the curve? 1. Right, so the whole area to the right is 0.9554. You do 1 minus that. We can find that missing part, correct? What do I get when I 0.0446? Someone double check me there, is that right?
What did you ask for?
1 minus 0.9554.
Negative 1.7.
No, just the 1 minus that. I'm not looking for the z-score yet.
You're right.
Okay? So the area now, that's that area, right? So we're looking for that 0.0446. You gonna go to the positive or negative side?
Positive.
Negative side, right? 0.446. What do we get? We get 1.70. Okay, so if I give you the area to the right, it's one more step, right? Because you got to find the area to the left in order to use the table. Okay, go ahead, find 0.9554 real quick on the positive side. What do you notice? Not the same, but it's opposite, right? You could also do that. No, that needs to be positive or negative when we do our z-score. Go ahead and find that next one here.
That's for 8.
Yep. We'll get to it.
What do you have? What is it? 0.904? It says 0.94 Claudia.
What about 0?
what's in, that's what these are. These are your tens places, your hundreds place. So that is saying 0.84. or 0.94. This is just your hundreds place, and this is your tens place.
So you're saying that it's 194.
Okay, so we need to find that area to the left, right? What's that area to the left? 0.8264. So then that's what we look up, right? 0.8264. What do we get? .94. Okay. Questions there?
What? Oh wait. I'm good.
Okay. Okay. Now what if I give you something in between? Looks symmetrical, doesn't it? The fact that it says negative z and z, that also tells us that those two z-scores are the same distance away from the mean. Now, what's going to help us is finding those missing areas. What's remaining between those two tails? If 93% of the curve is between those two z-scores. 7% left, right? Or 0.7 left? 0.07, I mean? So then we got to split that up also, right? Half on that. What's half of 7%? 3.5. So which z-score can I figure out? The negative z one, can I? I got the area to the left of that. Okay. So we're just going to go look. 0.0350. Does that one pop up? Oh, is there one that gets close to it though? Like there's two scores that surround 0.0350, 0.0351, 0.0344. Which one is closer?
.351, I think.
Yep. Oh, where was it? Okay, 350 falls between those two, right? So when it comes to that type of situation, you go to whatever one is closest. This is 1/10,000ths away from it, isn't it? That one's 6/10,000ths away. So that one's closer. So that's the score that you'll go with, the negative 1.81.
Actually, wouldn't it be 1.81 because the negative number is negative z?
So that negative z just tells us that that's going to be a negative. So that negative score is that negative 1.81. That's labeling it to tell us that those are the same distance from the mean. We're to the left of the mean,
Yeah, but
right?
it's asking for z, not negative z.
It's asking for the z-score. So the one to the left is at negative 1.81. Ryan, did you have a question? Now, having that idea that those z-scores are the same distance apart, do I need to worry about, adding that 0.0350 and 9.300 and finding that z-score? I mean, you can, but I know it's the same distance away, right? So what's the z-score to the right?
1.1.
Just the positive one. Cause then, I mean, you can go look up 0.9650, 0.9650, 1.81. Same thing. So having an idea that this is symmetrical and those z-scores are the same distance from the mean, we can just, once I find one of them, I should have the other one as well. Just gotta do the opposite. Questions there? Have you noticed when it comes to these types of problems, it's all about finding the area to the left? And you can look up those scores. Okay. Alright, the amount of passing yards for NFL quarterbacks is normally distributed with a mean of 3,807, standard deviation is 620 yards. If Carson Wentz finishes in the top 7% for passing yards, he receives a $200,000 bonus. How many yards will Carson Wentz have to throw for next year to earn this bonus? So, let's just let's get a visual. Let that mean of 3,807. Now, quarterback down here, are they going to receive a bonus? No, you're throwing for less yards here, right? We said the top 7%. Can I find an area? 7%, that puts us in 0.07, right? So what's the area to the left of that? %, right? Or 0.9300. Am I able to find that z-score? What's that? So, let's put it this way. I can find the z-score, right? I know the mean and the standard deviation. Will that allow me to find the score that I need to get, or the yards that Wentz needs to pass for? You guys understand how I did this? Top 7%. Okay. So anybody that falls in this, okay, this is the standard curve. Okay, top 7% is here. So anyone that, well, he needs to fall within that area to get that bonus, correct? So we need to figure out that score right here, or that score or more, that's what's going to get him. So we find that z-score, and since I have the mean and standard deviation on top of that, I can find that specific yardage that he needs to get. So 0.930. Which one is closer to 0.9300? 9306, right? So we got 1.48.
Don't you mean 1.47?
Okay, which one's closer, 9292 or 9306? So when you're doing this, that's the one we're looking for, right?
Yeah.
Okay, what was it, 0.9292? 9306?
Oh.
That's 808, this is 608, right?
That's stupid.
Okay, so that's the one we're looking for. And what did we say, 1.48? Okay, so he needs to get a z-score of 1.48 or something greater in order to get that bonus, right? But that's that cutoff point. So we had a z-score of 1.48. A mean of 3,807. What was the standard deviation? 620? Is that information there going to allow me to figure out that actual yardage she needs to get?
Mhm.
Just like the first three problems we did, right? Z-score is equal to x minus the mean over the standard deviation. So 1.48 equals x minus that 3,807. Divide by that 620. What are my steps to solve? Multiply both sides by 620. What's that get me when I do that?
$90, 917.6.
9 what?
17.6.
0.6?
Yep.
If I add that over, so Carson Wentz would have to throw for 4,724.6 yards, correct? What's up here?
Oh, no.
He has to do that or more, right? He does more than that, that still keeps him in that top 7%. Anything less, he's not getting that bonus. Now, what if he threw for 4,724 yards? Is he getting his bonus? No. Okay. Football, they go whole numbers, right? He would not get that if he threw for that exact number. He'd have to have one more yard. So it's always gonna round up in these cases, correct? So, well, just leave it at that, 0.6.
It's like on a case by case basis. In this case, it's fine because like it's a numerical value that could technically be a 0.6 without compromising. But like if it asks for say how many years could blank, if it's just like how many years could they promise or something, that should probably be about a whole number because you know it really wouldn't make sense for that to be like 14 point something or other years. That just sounds crappy, you know.
We wanna be on the right side of that, right? So we need to get above that value.
I'm assuming on the test or quiz you'll tell us what to round to.
Yep. Questions on that one? Okay, so that's kind of a mix of everything, right? Finding that z-score associated with an area. Using that z-score and the mean and the mean and the standard deviation to find that actual score. So go ahead and give that last one a try there.
really, since, well, these, yes, but mostly because they're sturdy as heck, but the last few pairs I had kept on breaking because of outside forces, like dog. It's just, but what I'm really trying to do is, what we mean is, why wouldn't they just say it mean?
I can say it's conversion.
I'm good.
Yeah, I got it. On the negative side.
I look at them.
So you got 0.0. You look for it on here.
Yeah, I did that.
Yeah, and what was the?
It would be 2.0. It's negative 3.05.
I don't know why you didn't remove the.
No, I got it. Yeah,
Here, why haven't you?
Yes.
Okay, you know that, now I got these scores, I got the mean and the average, right? And the standard deviation, can I find how many years then, or that actual score?
If that's the.
I don't know. It's too early in the morning for this.
That's, I just use that. I don't like. Really write it into like this one, that manipulates it. But I think I'll be easier than the average.
We're on the right track.
It's just what I do.
Okay, did everyone get that set up?
No, I've been.
Okay, now, if you're a company and your product lasts an average of 13 years, are you gonna give the people that last more than that refunds? No. So we're gonna be on the left hand here, right? When it falls really short of that average, those are the people we're gonna give refunds to, or, warranties, correct? So that 2%, it's not very likely to happen, is it? So that unlikeliness, that's the one we're gonna refund. Okay, defective product or something. So, I got that 2%, can I find the z-score associated at that point then? Yep, you looked up 0.02, what was it, negative 2.05? Yep. Okay. So we're actually trying to figure out that year that's gonna happen, right? This is what they're gonna put on their packaging, guaranteed for this many years. Well, short of that, those are the people that get the warranty. So if I got a z-score of that negative 2.05, we had a mean of 13 and a standard deviation, what was it, 2? Now I'm actually going to try to figure out that year they're going to put on the packaging, correct? So, again, z is equal to x minus the mean or average divided by the standard deviation. Plug in what we know, right? Multiply both sides by 2.
Just slow down.
Last step then. What do we get?
8.9.
that packaging, they're gonna probably say 8.9 years.
Probably gonna say 9.
Well, if they put 9,
Oh, actually, no, they're gonna put it.
that puts us to the right of that, doesn't it? That's gonna guarantee more than 2%. Well, not
Not
guaranteed.
necessarily, because our negative 2.05 is also rounded.
Yes, they'll round down, or they're gonna break it up into a monthly, or something like that. They don't wanna pay more than 2% out, right? So they're gonna have to go further left on it, which makes it even less time, correct? Now, for our sake, we'll just say 8.9 years. They just don't wanna go beyond that, right? They don't wanna pay more than 2% of their people's, or their customers. Questions? Test is Friday. Okay? Yeah, so that's everything for this chapter. Yeah. We'll take a quiz Wednesday, test Friday, cumulative test on Tuesday next week.
Claude, did you stop this?
Oh.